to this equation, we're trying to match the left and right side. Okay, the probability is 0 to 1, and the right side is a continuous variable, which is xi. And then if you try to relate odds with this, we see that probability is not good enough. So we say, okay, let's replace it with odd. Okay, we already talked about what are odds. So p over 1 minus p, that means p is the probability of success and 1 minus p is the probability of not success. And then this is the odd O. Okay, and then we say, okay, instead of p, let's use odds. Okay, instead of probability. And now what we do, so I have already told you the odds ratio varies from 0 to infinity, okay, instead of the probability, which is 0 to 1. So 0 to infinity, and then we take log on both sides, okay, natural logarithm, which is of base e, where e is the Euler's number, which I already talked about. So now if we take natural logarithm on both sides, you see that logarithm varies from minus infinity to infinity. That means log of the odds varies from minus infinity to plus infinity. You have to remember one thing, that they are undefined both at 0 or 1. Okay, so if it's 1, then the in the denominator is 0 and then it's undefined. And natural logarithm, if it's 0, then this or the top is 0. So this is natural logarithm of 0 is also undefined. Okay, so these are undefined both at 0 and 1. So they will never touch 0 or 1 and go for asymptotics. And now you see, so this actually the left hand side and the right hand side matches in range. Okay, so what we are doing, we are taking a real number value and predicting the real number outcome of the dependent variable based on the independent variable. But what we want actually to map it in a probabilistic range 0 to 1. So we have to take a kind of inverse of this function, which is ln, log of odds. Log of odds is also called a logit function. Okay, the inverse of a logit function is a sigmoid function. What does it do? It actually takes a real number, sigmoid function transforms a real valued variable into something that represents probability. Exactly, that's what we need. And how we come from logit function to the sigmoid function, I have done the calculation here. You see, if it's a logarithm of p over 1 minus p and the base is e, remember natural logarithm's base is e. So from here you come here, okay, so then we take out the logarithm, then it becomes the exponent, okay, p over 1 minus p equal e to the power a plus bi times xi. And then from here, then if we just do a basic algebra, we'll find that p equal to this. And then if you divide both denominator and the numerator with e to the power a plus bi xi, this will become this. This is exactly the sigmoid function which we have introduced at the beginning. And the sigmoid function, as I said, it transforms a real valued variable into something that represents probability. So you see, initially we started to map it, that we said, okay, our line, when it predicts something, it does not predict a categorical variable. Then we said, okay, instead of just y, then replace it with p, which is the probability, which varies from 0 to 1. But p directly does not make sense, so we replace it with the odds function, take logarithm on both sides, and then we use the exponents formulation to reach that equation where we say that whatever be the value, if we know the value of a, the intercept, and the b with the slope, then we can easily calculate the value of the the probability of success. That means if it becomes 1 or things like that. So the larger the real number predicted, and then the p will be closer to 1. Okay, so we have to understand that. And the logit function maps the probabilities to the full range of real numbers. And the sigmoid function is exactly opposite. It maps the a real valued variable into the probabilistic domain, which is 0 to 1.